So guys, next we will going to discuss the concept of broadcast address. So when do we use the broadcast address? We will use the broadcast address when we want certain set of machines to receive and process the same packet. So all receivers in the domain should receive the packet through broadcast address. So domain here means the same broadcast domain, that is all the machines present in the same subnet, right? So broadcast address is used when we want all the machines present in the same subnet to receive and process the packet. Now, there are two types of broadcast addresses, the MAC layer broadcast address and the network layer broadcast address. The MAC layer broadcast address is all bits ones. So the MAC layer broadcast address is very simple. It has all its 48 bit as 1. So in hexadecimal notation, we represent the MAC layer broadcast address as all Fs, right? It means all 48 bits of broadcast address will be 1. Whereas in network layer, we have already discussed that given a IP address and a mask value, how to calculate the broadcast address of that particular subnet. So in our topology, we have shown a subnet in which the machine A, B, C and D are present. So what will be the broadcast address of this subnet? The broadcast address will be 11.1.1.255/24. This will be the broadcast address of this subnet. And of course, the network ID will be 11.1.1.0/24. This is the network ID, whereas this is broadcast address for this subnet. Now let us suppose that in this subnet, the machine A wants to send an IP packet such that all nodes in the same subnet receives and process it, right? So in order to do so, node A should specify destination MAC address as broadcast address, which is simple, all bits as ones, and the network layer broadcast address will be 11.1.1.255. If the machine A generates a packet in which the destination MAC address specified is this value and the network layer IP address and the network layer destination IP address specified is 11.1.1.255, then all the machines in the same subnet will going to process the packet. Why they will going to process the packet? Let's see in brief. Now, as you know that every machine runs a TCP IP stack. When the machine receives the packet is picked up by the physical layer and is handed over to the data link layer. Now, data link layer uses the MAC layer rule to decide whether to accept the packet or to reject the packet. The MAC layer rule says that if destination MAC address in the packet is equal to the MAC address of the receiving interface, or destination MAC address is a broadcast address, then data link layer accepts the packet. If this criteria is not met, then data link layer rejects the packet. Now when data link layer accepts the packet, it means data link layer chops off the MAC header and hand over the rest of the packet to the network layer, right? So this happens when the data link layer accepts the packet. And when the network layer receives the packet from the data link layer, the network layer imposes IP rule on the packet to decide whether to accept the packet or to reject the packet. So the IP layer rule says that if destination IP address is equal to IP address of the receiving interface, or destination IP address is a broadcast address, then accept the packet, else reject the packet. So here, accept the packet means that the network layer will chop off the network layer header and passes the rest of the packet to the layer above it, that is the transport layer, right? So whenever the machine receives the packet, the machine imposes the MAC layer rule on the data link layer and the network layer imposes the IP layer rule at the network layer of the TCP/IP stack. Right? So if the machine A generates a packet such that the destination MAC address specified in the packet is a broadcast address and the destination IP address specified in the packet is also a broadcast address for that subnet, then rest of the machines in that subnet will going to accept and process the packet. So this is how broadcast is done. You have to specify the broadcast address at two levels, that is at data link layer level as well as at network layer level. So finally we will take a look, that is at the holistic view of a network, that is how networks are usually formed and organized. You can see that in this example there are three subnets. So this is the subnet A, which has the subnet ID 11.1.1.0/24, and you have a subnet B which has the network ID 12.1.1.0/24, and you have a subnet C which is actually a subnet on a point-to-point link, and it has a network ID 13.1.1.0/30. Right? So you can see that the mask value for subnet A being used is 24. It means maximum 254 machines or devices can be attached to that subnet. And the same is true for the subnet B. And for the subnet C, the mask value being used is 30. So in this subnet C, strictly two devices can be present. Right? So subnet 11.1.1.0/24, that is subnet A, and subnet B can have maximum of 254 machines. And because we are using the mask value 30 for a subnet C, we cannot attach any other machine to subnet C. Why? Because we are using point-to-point link. So practically the point-to-point link will not allow us to attach a third machine, and conceptually also using a mask value 30 we are debarred from attaching the third device to the point-to-point subnet, because we do not have any assignable IP address left to be assigned to that third machine. So if packet with the destination IP address is equal to 11.1.1.255 and MAC address is equal to the broadcast address arrives in subnet A, it will be accepted by all the machines in subnet A, that is machine A, machine B and machine C, as well as the router will going to receive the packet and will going to process it, because the packet is being broadcasted in that particular subnet. So we are done with the IP address mathematics, and in the next module we will going to discuss the L2 routing. Thanks guys.